As I said earlier, I'm Allison Gray, and I'm going to tell you a little bit about GO-BGC data. So we've heard some things already from Yui, and really I want to say that I am going to be up here giving this talk, but really all of this is really based on work of the GO-BGC data team. We're all listed there, led by Tanya Maurer at Embari. We also have Emily Clark, Nicola Kusuwait, and Josh Plant are the sort of key data team members. So really, everything you see is thanks to their hard work. And I'm really just not. Okay, so if there's nothing else you remember from this particular presentation, it's that you should go to our website, gobgc.org/data. This is where all of the information that you need to get started using the data, as well as find out information about the ship and ancillary data, all right here. And but just to, I'll go through a little bit more detail. So as we've mentioned before earlier, GO-BGC is really part of this broader program, BGC Argo, which is part of one Argo. And the data system also is part of the larger data system. But I'm just showing you this map, which is sort of a different version of the ones we've seen, because this shows all of the profiles that are in the Embari data system. And you can see we've almost got to 500 total floats. And I think we'll be in the next few days, because we have 22 to be deployed. But you can see that there's a lot of data. The little dots are the ones that are no longer operational, but many parts of the region have lots and lots of data. And then, right, the GO-BGC, SOCOM, US contribution to BGC Argo is just one part of the larger international program, which is kind of deployed, depicted in this map, where we see active floats as of last month, and the ones with the circles are the 6 sensor floats. And then you can, this is from the BGC Argo website, you can go and see a lot of statistics about all the different data types on the different variables. The data management for GO-BGC data is a really complex process, which is kind of depicted in this schematic, which I'm not putting up here for you to sort of try to understand, but just to show that there's a lot of different parts. And the video, which is linked here, and also you put out, it's one of the videos from the 2021 workshop. The video is given by Tanya at Embari, and it really goes into a lot of detail. So lots of information there. It's 35 minutes. It's very helpful if you want to check that out. So if you click on, and you're in that data part of our website, one of the tabs is data access and visualization. So you go there, it's like that. And what you can see are all these different tools. Some of the things that we mentioned are here along with some other ones. So lots of different tools to visualize float data, including web OGB down at the bottom. But also if you want to download the data yourself, it gives sort of these 4 different options here. There are others, but these are sort of the main ones, that, at least from the GO-BGC and SOCOM data, that we sort of recommend you use. Yes. Okay, so the Argo GDAX, which is where you can get all Argo data, not just BGC Argo data. And there's some information here. I'm not going to kind of go through all the details. Tanya does a really nice job of going through everything in the video, and also in the tutorials. I think we'll get into some of that as well. But I did want to say one thing, which is that you may have heard this thing called an SPROF file. That's when you go to the Argo data system and you download BGC Argo data. There are many different options. We can talk about details of what those options are, but really for using the data, what you want is the SPROF files. And the reason is because all the different sensors, this is sort of depicted for sort of different cycles, all the different sensors measure at slightly different pressures, right? But we want to know what the pressure, or what the temperature, oxygen, chlorophyll, nitrate, and PAR are at one sort of co-located measurement. So this SPROF file takes this mess and sort of converts it into something that is sort of on a merged pressure axis for each profile. So very helpful. And basically, these files, you can still download these, but they're very, very, very big files. Because of the way that the Argo data is stored, these files are gigantic to work with, whereas these are much more manageable. Okay. So, question?
I was going to quickly ask, when you do that revision, do you use a portion of data?
No, so they really do try to, the philosophy of doing this is to minimize the adjustments. So the data is, you can see it's not that they sort of bin the data all to be at 220 and 221. They sort of retain they try to retain the original characteristics, but just merge things, adjusting as little as possible. Yes. Okay, so I'm going to just kind of touch on a few things in terms of the GO-BGC data system. This lovely diagram was produced by Tanya, and really shows the sort of different elements. And I'm just going to kind of go through from starting when we deploy the float, or even before we deploy the float, all the way to like the final unified standard. And just to touch on a few things that weren't sort of new developments since the last workshop. And so metadata is an important part of our data system. It's the calibration files, the float deployment that files, all that stuff. That sort of happens for a data user. This stuff all happens on the back end. So you really don't need to know much about that. But we have worked on, in terms of the data system, recently incorporating all these new float types and sensors that you mentioned. The next part of the data system is the real-time processing. And this is very important. Unlike temperature and salinity data, most BGC sensor data needs to be adjusted in order to be usable. So really say only use the adjusted BGC data. And you can go on our website on that data page. You can find all these videos where it's nicely keyed up to where you want to go to learn from UE 2 years ago about how these data, how the different measurements are adjusted. And, but yeah, essentially, highly recommend that you only use the adjusted BGC data. And it can be adjusted in real time or adjusted in delayed mode. So there will be, yes, question?
When you say adjusted, do you mean by like the adjusted values in the, for example,
exactly.
Files?
Yes, exactly. So for the Argo files, the SPROF files, these will be listed under like deoxy adjusted. Yes. Okay. So a few new things that are either about to come online or have been implemented recently are in terms of the real-time processing is that Envari is in the process of implementing this new nitrate temperature correction as a paper that just came out led by Josh Plant, and this is a figure from that paper. I'm not going to kind of go into all the details, but essentially a very low nitrate values. The old nitrate correction process was highly correlated with temperature, and that's been corrected now so that we should get much better measurements near low nitrate concentrations. We're also working on implementing an oxygen response time correction. This is kind of shown here. These two models, they almost are on the same line, except there's a slight deviation at low oxygen. So we're working to implement just basically response time correction for the fact that the oxygen sensors are very slow. The next step of the overall data system is this delayed mode quality control, DMQC. This is an acronym you hear a lot in Argo. And this is the paper that Yui mentioned, led by Tanya, that lists in all the details you could ever want to know about how the data are adjusted. And this is a plot from that paper showing basically float, oxygen, and then this is our bottle value. So when we deploy the floats and we get a cast from the deploying ship, we can compare it to the float measurements after they've been adjusted in order to understand how our accuracy is. And this is the sort of computer program that Tanya and the Embari data team have developed called Sage that lets you do this. And that code is all available online as well. Okay, so a few updates. We recently started incorporating new reference products. So these are data sets such as ERA5, which we use for the oxygen optode air calibration, or ESPER, used for the pH reference comparison. These are things I think that have already been incorporated as of the last processing. Another thing that the GO-BGC Embari data team do, which is outside of the Argo system. So if you want to get any of the things that are measured by a float, probably the SPROF files going to the Argo data system is the recommended path. There's sort of one caveat, which is that we can use the pH data to derive other carbon products using the standard CO2 steps. And this is something you could do yourself by downloading the SPROF files and then converting it to DIC and PCO2, for example. We do that for the community, but those data, derived carbon parameters aren't in the SPROF files. They're only in the Embari files. So if you want to get those, I will show you how to get that data, but this is, I would say, an area of active research in order to understand exactly what is the best method to do this and what the uncertainties that you get in the end really are. So I think we can talk more about that for anybody who's interested at the break. And then Embari is also working on a new park depth data product that many of the floats, while they're drifting at depth, are also recording things like biooptics. Some of them record temperature, pressure, some other things as well, but mostly it's optics and temperature, and that data are now available from the FTP site at Embari, and I think are going to be incorporated into the Argo trajectory files at some point in the future. Okay, so in terms of archiving, if you want to write a paper with float data, you could go and download all the data yourself, but if you want to get like sort of a snapshot where you get one DOI, so you can easily cite that data and it's sort of preserved, so anybody who wanted to could go back and use that data in the future to redo your calculations. There's two sort of main archives. There's this GO-BGC SOCOM data archives. All of these are linked on the website, but these are what you mentioned. They're the triannual archives. They have the derived carbon parameters. Something to note. The other thing is the SPROF and files from the Argo data system, and those have recently we started adding a monthly snapshot of the SPROF files. So this is just the BGC files. If you want to go download each month, they'll update it to a new archive that includes all the SPROF files. And then that way, you don't have to download all of the core files if all you want is the BGC files. Questions?
These monthly are cumulative to that.
Exactly. Okay, so then just lastly here, One Argo is, as you mentioned, the overall program in BGC Argo is definitely part of One Argo. Every GO-BGC float is a core Argo float as well. And I just wanted to point out, though, that on the BGC Argo website, there's a lot of other information on data management, as well as sort of assessing different parts of the data system in terms of international contributions. And want to know more, we can. But I'll just leave you with this as my take-home messages. So within the Argo system, the synthetic profile files are the easiest way to access the data. You do only want to use the adjusted BGC data, which is flagged with either A or D, and you want to use the good quality data. People have already gone through and flagged bad quality data. Most likely you don't want to be using that for your analysis. So make use of those quality flags. If you want the derived parameters, use the Embari files. And then I like this quote from Tanya: always look at the data, trust but verify. So, you should always just look at the data and make sure that it's looking like what you expect, and then go from there. And then, as I said, our website has lots and lots of resources. So with that, I think we can have coffee. I'm also happy to answer questions. Oh yeah, so yes, I think it depends on exactly, I think in which case the eighth is being mentioned.
So I was going to say, thank you. Good question. The Argo flagging system is very rich, and so there are other flags. One is good data, right? But there's also in this SPROC, if you interpolate a value, that's an 8, I think. And if it's an NPQ corrected value, it's a 5, which is created data. But they're all good. The what do they call that? The flags, if they 5s and 8s are also a 1.
Good, yeah.
So you have to look beyond just 1. You have to look at 5s and 8s. I made this mistake and did a whole analysis on flag 1 data, and then realized I was missing a whole bunch of good stuff.
Yeah.
So,
Thanks for pointing that out, because yes, I think this is sort of, yeah, I should update that, because
so
it's out of date with the SPROC.
flag 1, 5, and 8 are all good.
2, right?
Well, yeah, 1, I like 2 is potentially good, or 2 is sort of like probably good. I think probably good is the way. But yeah, so 8, if it's been adjusted, like in an SPROC file, it will have an 8 on it. Sometimes you also see 8s might be for under ice data. If we don't have a GPS fix, it can be flagged as having a location as an 8. So there are sort of these nuances, and yeah, as you work with the data, you'll learn more and more of these things. The Argo data system has an enormous manual handbook, so all the information is there, although it can be hard to find it. So you can, please reach out to any of the data managers or the contact people if you do have questions that you can't find an answer to.
I want to add to the FAQ page on our website is, so we put it together rather, not hastily, but
it's the basics.
We would really appreciate, if you have I wish I knew this, when I was starting with things like that, please tell us so we can add it on to the FAQ, because it's hard for us to kind of, think of some of the issues, right? Because we've just been in this for 10 years now, so it's just if we're going to crowdsource the FAQ, and so please send us feedback.
Even?
Yeah, I'm really interested about the new data set you're talking about regarding the time series measurement of the GO-BGC data in the flow path. I'm curious how the global coverage is like. Does most of the flow equate with the sensor continuum measurement GP between the 3?
So no, I don't believe that many of the floats that have been sort of deployed in the past maybe are not measuring BBP at the parking depth, but they're capable of doing it. So there was actually within the Argo international Argo community, there was a working group that was looking at the parking depth data and sort of making recommendations for which sensors should measure at parking depth and at what frequency and these sorts of things. And because it's not been something that's been widely used, even for temperature, and it's not been very standardized. So I think the recommendations from this working group are going to be, sort of implemented. It will probably take time.
We have park data for BBP.
Yeah, right, but the Embari files do. So that was sort of internationally, I'm not quite sure where things are, but the Apex floats and I think the Navis ones, we do have those. And so they're on the Embari FTP site, and I think we're getting them into the files too.
You showed a diagram on the park that the float was.
Oh, no, that was just somebody made that cartoon. No, the float doesn't do that. Hopefully not. Hopefully not.
We just flooded.